Today, lesson 21A, rational number operations. Our focus as of late has been on strictly integer work. Today we shift that to rational numbers. And when we talk about rational numbers, we're now talking about positive and negative, decimals and fractions, mixed numbers that we're all adding in there. Okay? So today we're going to find the sum or difference of rational numbers. And we're also going to do a little bit of estimating and trying to make sure whether the answer we got, whether that makes sense or not. We'll also be applying some of the distance formula ideas that we talked about last week. So let's go ahead and get started. From 6th grade, the definition of a rational number is any number that can be written as a fraction. And that's not what you should be filling in your blank area with, because that's the definition from last year that you may have seen. I think that's also the way I phrased it earlier this year. But the official definition of what a rational number is, as I go through some examples here, proving that that's really what it is, a number that can be written as a fraction. 0.6 is rational because it's 6/10. -5 is rational because we can write that as -5 over 1. 2/3 is rational because it's already a fraction. 75% can be thought of as a rational number because it is 75 hundredths. Well, the official definition of what a rational number is this. This is what you should be copying down. It's any number that can be written in the form a over b. And of course, a over b is a fraction, where b does not equal or cannot equal 0. And the reason is because we cannot divide by 0. And we will investigate that idea a little bit later this week. So that's the official definition of what a rational number is. Any number that can be written in the form a over b, where b cannot be equal to 0. So our first problem today is this. In Numberline School, there is one straight hallway. The numbers on the classrooms indicate the distance from the main office, which is at 0. Mark the location of the following classrooms on the map of Numberline School below. So I'd like you to go ahead and do that. And the reality is the idea of plotting all of these rational numbers on a number line, that's straight from 6th grade. You should have done some of that stuff last year. All right, so here's what we should have, and so why don't you just look up here and make sure that this is what yours looks like. The office is at the origin, at 0, right in the middle. Mr. Bowen's classroom is at -3 1/4. And Ms. Abe's classroom is at 3.5. 3.5. Ms. England's classroom is at -6 1/4. So I'm just kind of giving approximate locations here. Mrs. Chidester's class is at 5.25. Mr. Frank's class is at -8 1/3. And Mr. David's class is at -5.2. So that pretty much takes care of the location of all of those classrooms. Now what we're going to do is we're going to answer some questions based on the placement on the number line of those classrooms. And here's what I want you to do. I want you to answer all of them individually. So basically we're just finishing off the front side of our notes here, okay? Down to the bottom question, which says, how about 21 and 7/8? So I'm going to have you answer those by yourself, all of them. And then we will shoulder partner what we came up with, and then we'll go through each of them. So you're basically finishing off the notes of the front page, front side. Okay, I'll give you a couple of minutes to do that. First problem. It says, whose classroom is further from the main office? Ms. Abe's or Mrs. Chidester's class? Estimate and then find the actual distance. Well, first of all, whose classroom is further? Chidester, okay. So then find the actual distance. Well, hers is closer by 1.75 units. Number 2. It says Joe has Mr. Bowen's class first hour and Ms. England's class second hour. How far must he walk to get from Mr. Bowen's class to Ms. England's class? Well, how far would he have to walk?
3 units.
3 units. How did you do that?
I just counted the distance from on the number line, but you could also just subtract the.
Okay. Yeah, and we could also think about the distance formula that we talked about last week, right? Basically, that would look like this. Negative 6 1/4 minus negative 3 1/4. Negative 6 1/4 is Ms. England's classroom position, and negative 3 1/4 is Mr. Bowen's classroom. So we could have just used the idea of the distance formula, but regardless, it should be 3 units. Number 3. It says, what is the distance between Mrs. Chidester's class and Mr. David's class? What would that be? 10.45 units. And how did you get that?
I used absolute value.
So you use the distance formula, right, with the absolute value. And that's good, because we're linking that up to something that we did talk about last week. And if you do it that way, just take and subtract the 2 endpoints. One endpoint is negative 5.2, and the other one's 5.25. Subtract those 2, take the absolute value of that. We get absolute value of negative 10.45, which is 10.45 units. Number 4, what is the distance between Mr. Frank's, I don't know whether that's Frank or Frank, but I guess it doesn't really matter, and Ms. England's class? So what's the distance between those 2 classrooms? Yes? 2.08. So did you convert to decimals or something? Because I don't think it would be exactly 2.08. Yeah. 2.083 repeating? Yeah, so you basically converted to a decimal as well. I would have left it as fractions, which what you gave me is 2 1/12 units. And once again, you could use the distance formula, subtract the 2 endpoints, take the absolute value of that, so 2 1/12 units. All right, next question. It says, would we be able to plot a location of negative 18.75 on the line? And then how about 21 7/8? Well, I walked around and looked specifically at this one, and most of you answered no and no. Well, the number line has arrows going in both directions, right? That means it goes infinitely in both directions. So we could, if we took the number line that's in your notes and we extended it out. So sometimes that is what we would need to do. We would need to extend it out. So you need to be careful with how you might answer a question like that. We can plot any real number on a number line just by extending it out. Okay? And sometimes that's what we have to do. All right, so specifically number 4 deals with the idea. I noticed that some of you went straight to converting to decimals. But in order to add or subtract, we must have the same units. What I mean by same units, here's an idea of that. 3 apples plus 4 apples, that's 7 apples. 24 plus 7, where you line up the ones digits to make sure that it's easier to add, that's 31. 3.2 plus 4.01, where you line up the ones and the tenths and the hundredths together to make 7.21. 1/2 plus 1/3. Right now, those are not the same units. But if we find the common denominator, we now have what we could think of as the same units, and that's clearly 5/6. Here's some examples of things that are not the same units. 3 apples plus 2 bananas. That's not 5 apple bananas. Never seen an apple banana before. Might taste good, but I've never seen one before.
Crunchy bananas.
Yeah, it might be. When you add 24 and 7, you don't put the ones digit underneath of the tens digit. Because if you do that, you don't get things with the same units and same ideas with adding decimals together. That's not how we add decimals. We have to line things up to create the same units. And we don't certainly deal with fraction problems like that. 1/2 plus 1/3 is not 2/5. We have to convert to same units before we can figure that out. Okay, so make sure that you don't make mistakes like that. One of the ways that you may have dealt with fractions last year And I don't want anybody to think, oh no, more modeling. No, we're not going to deal with modeling with regards to fractions because it doesn't work very well with negative fractions. But here's one way that you may have done this last year. 1/2 plus 1/3, and then when you add those two together, we need the same units. So we would need to convert them or separate the rectangles in the same number of units, which would be 6, which is why the common denominator is 6. And then when we put those together, we can see that when we add those two things together, we end up with 5 out of 6. Okay? Just to make it clear on what we should be doing here, negative 12.7 is about negative 13. And negative 17.7 is about negative 18. So if we were to estimate that, and the symbol for estimating, by the way, looks like a squiggly equal symbol. When I write that, that means that's an indication that I'm approximating or estimating. So I'm estimating negative 12.7 plus negative 17.7 to be about negative 31. Okay? Now when we add those two together, we have a negative 12.7 and a negative 17.7. We have 0 positives, but we have 30.4 negatives. So this is the exact answer. This is the estimate for that. And that's how we want to do each of these problems today. Okay? I would like everybody to try number 2 and number 3. All right, so a decent estimate for number 2, 15.7 is about 16. Negative 9.22 is about negative 9. So that would make that approximately 7. So no matter what we get, it better be close to positive 7. Okay? When I look at 15.7 plus negative 9.22, I see that as 15.7 positives and only 9.22 negatives. And I can see that I have more positives than I do negatives, which is one way that it makes, that's supposed to be a 0 right there. That's one of the reasons why it makes the answer positive. So it's positive. Now to figure out how many more positives than negatives, we need to subtract to figure out how many more of these we have than these. So you just go into subtraction mode. And I'm trying to write as cleanly as I can. Oops, I did not need to do that. So it should be positive 6.48. Correct? That's the exact answer. The estimate is 7. And so we would do sort of the same kind of thinking for number 3. In number 3, I can see that I have more negatives than I do positives. And I'm going to try and clear off some room here. So I have 3.511 negatives and 3.3, and I'll fill in to make the same units, some zeros there, and only 3.300 positives. To figure out how many more of these I have than these, well, that's when I need to subtract, and that would be 0.211. And so the exact answer there is positive 0, or excuse me, not positive. We have more negatives. Negative 0.211. An estimate, this is about 3. That's about negative 3.5, so that's about negative 0.5. So something that's reasonably close. Okay, I would like you to now do number 4, 5, 6, and 7. Do all 4 of those problems. All right, and number 4, this is subtraction. Anytime I see a subtraction problem, I add the opposite to turn it into an addition problem. And so, don't know why I just did that. Add the opposite. And so in this situation, I have 14.6 negatives and 4.9 positives. I clearly have, or it should be clear to you, more negatives than positives. That's what makes the answer negative. And I have 9.7 more, so it's, the difference is negative 9.7. Same idea. In number 5, add the opposite. I have 22.6 positives and only 7.81 negatives. I have more positives than negatives. If you want to figure out how many more positives than negatives, and I'm going to need to shove a 0 in there to make sure I have the same units, subtract, and that will tell you how many more positives you have than negatives. And that would be 14.79. Number 6, add the opposite. We have 24.52 positives and only 2.9 negatives. We have more positives than we do negatives. In fact, we have 21.62 more positives. And then number 7, add the opposite. We have 34.8 negatives because we have 18 negatives and 16.8 more. We have 0 positives. That's what makes the difference, negative 34.8. So as I've already discussed in the background knowledge, when we're dealing with fractions, we need a common denominator to make the same units. So, if we have a problem like this, what is the least common denominator? That's not a trick question. What is it? 24. It's 24. You could use 48, but then you're definitely going to have to reduce. So we're going to convert to equivalent fractions, fractions that have 24 as a denominator. So we will end up with 3/8 minus 20, not 3/8, 3/24 minus 20/24. And now, the step that people tend to skip or do in their head and do it incorrectly is that step right there. Since we have a common denominator, we can put everything over that common denominator. And now it's just a matter of figuring out what 3 minus 20 is. Well, that's negative 17. So 1/8 minus 5/6 is negative 17/24. If we have mixed numbers, in my opinion, what you should do is you should convert to improper fractions. So we should think of negative 1 and 7/8 as negative 15/8. Okay? And then I'm going to convert 3/4 to the common denominator of 8. So what I'm saying is this. Whenever we have mixed numbers within an adding or subtracting problem, in my opinion, the best thing to do is to convert to a fraction, or what we typically call an improper fraction. And then when we do our math, we end up with negative 9/8, but that is negative 1 and 1/8. Okay? I want you to now do 10, 11, 12, and 13. So go ahead and finish off the rest of the problems, and then we'll shoulder partner them. Number 10, you're going to see me do all of these the same way, and I'm bringing it up because some of you, for this problem, you just went back to the way you first learned simply because after you added the opposite, it just became a regular mixed number problem, and that's fine. But I'm going to be consistent and do every single one exactly the same way, okay? So I'm going to convert to improper fractions. And one of the other things it does, this kind of links up what you have to do with multiplying and dividing as well. From here, we find a common denominator, which we don't have to do when we multiply or divide. But we end up with 125 over 20 plus 32 over 20. That's 157 over 20. Now convert that back to a mixed number. 20 goes into 157 7 times, the remainder of 17, so therefore it is 7 and 17/20. Number 11, we don't have to worry about converting to improper fractions or fractions because we already have fractions. So we just need to find common denominator, which is 12. The least common denominator is 12, so we have negative 9/12 plus a negative 8/12. Negative 9 and negative 8 is negative 17, so we have negative 17/12. 12 goes into 17 once with a remainder of 5, so therefore it is a negative 1 and 5/12. Any questions about either one of those two problems? All right, continuing on. Number 12. We should convert to improper fractions. So we have a negative 8/3 plus negative 16/5. Now we can find the least common denominator of 15. So we have negative 40/15 plus negative 48/15. That is negative 88/15. 15 goes into 88 5 times with a remainder of 13. So that would be negative 5 and 13/15. Number 13. Once again, convert to improper fractions first. That is 7/4 minus 15/7. The least common denominator is 28. So we have 49 28ths minus 60 28ths, 49 minus 60, which turns into 49 plus negative 60. That's negative 11 28ths. That's already proper, so we're good to go. Any questions about either one of those? All right, we are finished for today.